So hello and welcome back to my exploit development playlist. In this video we will solve the 7th challenge of Emporium, which is pivot. And let's first take a look at the challenge description. There's only enough space for a small rob chain on the stack, but you've been given space to stash a much larger chain elsewhere. Learn how to pivot the stack onto a new location, and here you have the download links to all the binaries again. And here we have some description why pivoting the stack is useful, but there's more. So in this challenge we need to know about the PLT and the GOT sections of the ELF binaries. Basically PLT is the procedure linkage table, and the GOT is the global offset table. And this challenge imports a function named foothold function from a library that also contains ret2win. And the function in the ret2win function in the libpivot shared object isn't imported, but that doesn't mean that we can't call it using rob. We will need to find the GOT entry of the foothold function and the offset of the ret2win function from the foothold function, so we can resolve the actual address of ret2win. And also we have to notice that the foothold function isn't called during normal program execution, and we have to call it first using rob probably to update its GOT entry. Okay, so much for that. So let's download the binary again. And I think we don't need to have the challenge description anymore. So let's get started. Let's take a first look at the security mitigations. So there's nothing unusual, just the usual things. So stack is not executable, but yeah, the same as the other challenges also. Let's take a look at pivot. And here it already says we need to call ret2win from libpivot, and the old god kindly bestow upon you the place to pivot. So we need to pivot our stack to here, and here we can probably send our rob chain. So this will end up on the stack, and this is the location of the stack here. And now we can provide our stack smash. And this we will probably need to use to pivot our stack. Okay, so let's open another window here. And we will use this to do our debugging and recon. And here we will write our exploit. So we can get the boilerplate out of the way right away. And we can import our binary here again. Also, we can import library, and then we can prepare our context. That is just the ELF we've just imported, and our terminal kitty in my case. So let's get our constants. So we need to take a look at how large the buffer is. So let's open pivot in GDB, and let's just run it. That was a bad idea. So let's hit this and then run again. Pick the first one. And we again have our offset at 40. So we can note that down already. 40. Then we want to fill our buffer with A's again. So let's do that. Times buffer size. Then we need to have some gadget to pivot our buffer, our stack, I mean. And we can use proper for that with the stack pivot switch. And that one seems perfect. Let's get that. So much for that. Then we probably want to find some other gadgets. For example, we want to have a gadget to load a new address into RAX. So let's see what we have. Let's just search for RAX, see what gadgets we have. And call RAX seems good. Jump RAX also. So maybe that will be useful. So let's just note them down so we have them for later. Like so. Let's see what else we have. Pop RAX, that seems useful. But we still need to get some kind of address. We can probably put an address on the stack. Let's see what else we have. This one seems helpful. We basically dereference RAX, so that's cool to have. Then we also need to have some way of adding an offset to RAX, because if we later have our function pointer in RAX, then we can call it. That's good. But we probably get our foothold function in here, at the address I mean, and then we still need to add our offset somehow. So let's see if we have some kind of add RAX. And this one seems good. In RBP, we add RBP to RAX. So let's note that down. Then we still need a way to load something into RBP. So let's see if we have a pop RBP. And this one seems perfect. Okay, let's think. What else do we need? Of course, we need to have the offset of the red to win. So let's just call this R2W offset, and we can just use the SO that we have. And let's just make sure how the functions are called. I think I did that wrong. Okay, there are not that many functions. Oh, of course, I have the wrong binary. So, of course, that didn't put out anything. Red to win. Exactly. So that's the name of the function. And then, of course, we need to subtract our foothold. And let's see. Foothold function. So put that in here. So far, so good. So here we saw when we call pivot, whenever we execute the program, we need to read and receive until here, and then the rest of the line is our new stack. So let's get that. Let's divide this into a new section, and this will be our first interactive part. So let's see. And we need to receive until pivot, and there is a space after that. And then the rest of the line will be the pivot address. You can just receive line, and system is a hexadecimal system. Yeah, for information, we can log that out. Let's see if we got the correct address. And we can output it as hex like that. And then we have basically the last information that we need, which is the pivot address. And that we can also need to have as an int It's a 64-bit pointer. So we can use the P64 here again to convert that, or to pack it, however you want to call it. And that's so much for that. And then we first need to fill in the buffer again. And then let's see what we have. We can pop an address from the stack. And that will just be our pivot address. So we need to pop that into RAX. So let's use pop RAX here. And after that, we can already pivot our stack to there. So, and that should already have pivoted our stack. And then we can prepare our final payload, which is the call red to win payload. And that is just a NOP instruction right now. Let's see if we pivoted our stack correctly. We of course need to have a last interactive section here where we send our call that, and we also we of course have the caret symbol here again, so let's use that and then also we can switch to interactive mode again. So let's disable the checksec information like that. And here we need to provide our pivot payload. And maybe we can just call the foothold function to see if we already jump there. That would be our first step anyways in payload here. Let's do that. So by Rob Emporium, yeah, that doesn't seem right. Pivot by Rob Emporium. Didn't we receive until here? Okay, let's see. Of course, we need to provide the double dot here. So let's see again. Okay, so that's perfect. We already got to the foothold function. And then it should be relatively easy, I think. From here, we need to get the GOT entry of this function into RAX. So let's see. GOT, and then pop that into RAX. And when we have that, we need to dereference RAX. So we get, here we have the function addresses in the GOT, and then we dereference that to get the real address where it is mapped. Then we can add our offset that we calculated here. And then we should be able to call into RAX, which now should hold the address of our red to win function. So let's see if we can do that. Ref AX. Then we need to get our offset into RBP. And our offset is of course and we offset, and then we can add those together, and then we can call into RAX. So see if that makes sense. I think it does. And yes, we got the flag, so that's perfect. So I think we got a little too much here. We didn't use that, but all the others we did use. So I think that's relatively clean and straightforward. I think we can remove that. See if it still works. Yep, it does. And with that, we've solved the pivot challenge from Emporium. And I hope we can also solve the last